All right, so this will be our last quiz. It's bittersweet. I think it's sweet, sweet. I don't know if it's bittersweet.
No, it's bittersweet
Is
because
it?
I really miss this class. This is my favorite class.
Oh, yeah, you're just trying to get a good grade on the quiz.
I'm just making sure my grade doesn't go below.
All right, here we go. What I'm going to do, I'll just go question by question. All right, so number one on the quiz, if you look at section 12.3, there's several problems where you have to find the area of the triangle. And there was a couple formulas that we learned to find the area of a triangle. Now you know your basic area of a triangle. What's your basic everyday area of a triangle? Base times height divided by 2. But that's not the one that we're using here, all right? Because they won't give you the base, or they won't give you the height, all right? So you don't know the height, and it's very difficult to find the height, but you got some other ways to find the area.
National Honor Society, you're going to have a meeting today during lunch in Mrs. Burns' room. National Honor Society has a meeting in Mrs. Burns' room at lunch today.
All right, so do you remember this? The area is equal. I think we wrote 3 different versions of it down. I'm just going to write one version of it down. Do you remember this? 1/2 BC sine of A. Do you remember that one? All right, if you look back on your notes, you probably see it. It's on the video. Then we had another one. I'm not going to write them down, but what would the other 2 versions be? It'd be 1/2. You got 3 letters of the alphabet, or on a triangle. Yeah, it could be AC, but then that would be what? Sine of B, right? The one that's missing, right? Because you got 2 out of the 3 right here of the sides. The side that's missing, that's what you're going to take the sine of. Make sense? Because you don't have an A here, so you take the sine of A. If you put AC, you don't have a B, so you put the sine of B. It could also be what? AB, and what are you missing? A C, so you put sine of C. Okay? So you don't really need all 3 of them. But that's what we're going to use, at least on this one. Let me just look. I'm looking at something here. Okay. All right, so I'm looking at numbers. I'm going to write this down here. So I'm looking at the homework from section 12.3, and you're going to have 3 problems on the quiz, okay? 1, 2, and 3, where you have to find the area of a triangle. And they are numbers 13 to 17. 13 to 17. Everybody see that? All right, so if you look on the homework from section 12.3, and you look at 13 to 17, those are the kind of problems that are going to be 1, 2, and 3 on the quiz. Make sense? All right. So let's pick one. Anybody have the book open? Numbers will be different. Let's just do the first one, number 13, okay? Everybody okay with that? All right. Get rid of that. Get rid of that. Okay. So number 13 looks like this. Looks like this, like this, like this. And they tell you that this side is 18. It's in feet. I'm not going to put the feet because I made this thing so small anyway. The bottom one is 20. And this angle is 38 degrees. Now they actually do this. They actually put a height in there, but we're not really going to use the height. You could find the height if you wanted to. All right, everybody see that? You could find the height and then go ahead and use this formula right here to find the area. But that's why we came up with this thing. All right, so you kind of put it all together. So you're not really doing 2 separate things. All right, you're just putting everything into this little formula right here, and then you can find the area. Yeah, it's being recorded. Okay? So this is what we're going to use. So the area, I'm going to write area instead of A because that's an A and it might get confused. I don't know. I have my pre-calc book. They use the letter K to represent the area. I'm not really sure why they picked the letter K, but they do. But anyway, I'm going to write the word area, so it equals what? 1/2. Now look what we got. We got BC sine of A. So if this is angle A, this would be what? Side A. So what would these two be? The B and the C. Does that make sense? So it's set up perfect for us, isn't it, to use this formula. So it's 1/2. B, doesn't matter which one you pick, 18. C, which is this one right here. And then you take the sine of that angle that's in between those two. So the sine of 38 degrees. So this is just a matter of putting into a calculator. You got to practice it. Okay, I harp on this all the time. Seems like all my classes I've been saying this. Okay, in CP geometry, you guys, algebra 2, and pre-calc, all the classes that I've been teaching, we're doing trig right now. And almost every day, every class, I say you've got to practice this on your calculator because sometimes it's not always that easy. This one's not that bad. But again, it depends on what calculator you're using. I say this all the time. Do not come to me tomorrow and say, Mr. Hamrick, I got this set up, but I don't know how to use my calculator. All right? Now is the time to figure it out. So you should have your calculator out. You should be putting this stuff in, and let's see what we get for an answer. Is anybody actually punching this in? See, like 1 or 2 of you doing it. So it's 110.8 is what the book says. 110.8. This was in feet, by the way. So this is area, so it should be what? Feet. What? Squared. Good. Okay. Check it on your calculator. Make sure, because people are using different calculators. You put them in a little bit differently, okay, depending on what calculator you're using. Because if I use just a regular graphing calculator, I would actually hit the sine and then 38. If I have the calculator like a little scientific calculator, like a TI-30 or something like that, I would actually put in 38 and then hit the sine. Do you see that? So it all depends on which calculator you're using. Sometimes you hit the sine first, then 38. Some calculators you hit 38 first, then you hit the sine. Then it gives you the same number, but you do it a little differently. So make sure you know how to use your calculator. That's all I'm going to say about that. Okay? It's easy, isn't it? Just got to know this formula. All right? Just know that formula. You could do it another way, couldn't you? You could have found the height. How would I find the height? Well, I know this side of this right triangle. This is the hypotenuse. That's opposite. That's where they get the sine from. You see that? Okay, so the sine of 38 is equal to what? Opposite over hypotenuse. And then you got to go base times height divided by 2, and it'll come out to that as well. All right, but this is a little more streamlined. If you can remember the formula, it's just so much easier just to put it into this, and you're good to go. We good? All right. Second one looks like number 15. So this one looks like number 13 on the homework. Number 2 on the quiz looks like number 15 on the homework. So when I put that little number thing, that means that's from the homework. All right, so here we go. We've got a triangle like this. Got a dotted line straight down the middle. I don't know why I'm doing this so small. Let's just do this. So number 2. It's actually an equilateral triangle. You don't know it right off the bat, but you will once we start working with this. Gabby, question. I'm sorry, you got to speak up. I did not. I don't think I did. I've got several homeworks sitting in my folder. I've graded all my quizzes and tests so far. It's just trying to get those homeworks done. To me, that's the least important thing to get back, right? I think it's important you get the quizzes and tests back the next day. Homeworks, though, have been a little issue because I've been doing a lot of other stuff. All right, what am I doing here? They put this dotted line right down the middle, perpendicular to that base. right? They tell you that both of these angles are 30 degrees. Okay? And they tell you the bottom of it is 40. And this is in yards, 40 yards. And you got to find the area of it. So on this one, well, no, we're not doing law of cosines on this. We haven't even, on section 12.3, we haven't even gotten to law of cosines. Law of cosines wasn't till 12.6. Okay? So we're going to do this without law of cosines. And that formula that we just talked about, that 1/2 BC sine of A, I guess you could eventually use it, but watch what we're going to do here. We could do this a couple ways. All right. If this is 30 right there and that's a right angle, what's this angle right here? That's going to be 60. Of course, this angle right here is what? 60. So what's this one going to be? It's going to be 60 as well. Agreed? All right. So we got to, so that means if this side is 40, what's this side going to be? That's going to be 40 and that's going to be 40. Why? Why does that got anything to do with? Yeah, because it's equal angular triangle, and equal angular triangles equal lateral, so that means all the sides are equal. So if they give this to you as 40, then these two automatically are going to be 40. So if you wanted to go ahead and, I don't think, oh yeah, they did it both ways. Yep, they did it both ways. Let's do it the way that area equals 1/2 BC sine of A thing. Because now, we had to do a couple things, but now we can use this. So what's our A? Actually, it doesn't make any difference. Doesn't matter if it's this angle, this one, or this one, does it? Because they're all the same. So I don't know, let's just use this one right here. So it's 60. What's the B and the C? They're going to be 40. So it's 1/2 times 40 and 40 sine of, well, you only got one choice because they're all the same angles, 60 degrees. And you could put that into your calculator and you should get 692.8. Try it. Anybody actually putting it into a calculator? Doesn't seem like many people are. What did I say it was? 692. Gabby is. She's the only one. All right, it's in yards, so this is area, so it's what? Yards squared. Don't know why you're not taking my suggestion on doing this on your own. All right, we got a few of you now. Now that I guilted you into it. Why are the rest of you not doing it? It's right in front of you. If you had to go to the bathroom and get a pass, you could go in there and get it, couldn't you? Because you do that every day. All right, so 692.8. Is that right? Anybody trying it? Is that what you got? Okay. We'll just stick with that way. All right, we'll say there's another way you could do it, but we'll just stick with that. That's a lot easier. We good? All right. Let's do another one. So number 3 on the quiz is going to look like number 16 or 17. It doesn't matter. So number 3 on the quiz looks like 16 and 17. It's a triangle where they give you all 3 sides, okay? I don't know, let's just do 17. So it kind of looks like this, like that. And they tell you this is 12. They tell you this is 12. And they tell you this is 16. All right, we have another formula because we don't have any angles here, do we? So there's no way I can find the area if I don't know one of the angles. Now you could, again, you could use like law of cosines to find an angle and then put it in, but that'd be too confusing. We have another formula. Do you remember the other formula when you have 3 sides? It's got a big old square root in it. Remember this? S. What does the S represent? Semi-perimeter. That's right. Okay. We'll talk about that in a second. So let's write out the formula. This is a formula you should know. If you want to get this problem right anyway, okay, you should know this formula. And we've talked about it. We've done this. It's S minus A times S minus B times S minus C. Anybody remember that? It's got a name, by the way, named after some old Greek guy. Remember it? Heron's formula.
We're leaving for a game. Me and I. Can you please record the lesson again?
Oh, you're leaving for a game. I thought you said you're looking for a game. Yeah, I always do, but I will.
All right, thank you.
Sure thing. All right, so what is the S? By the way, before I was interrupted, Heron's formula, do you remember that? Okay. Actually, I looked him up a little bit just to get some background information on him, and they really don't have a lot of information. They don't know exactly when he was born or anything like that, or when he died. They have a general idea. They know a lot of stuff that he did. One of the things that he did, I don't know much about it, but one of the things he did, he developed the first vending machine. I mean, we're talking like, what was it? Like 1200 BC, 1500 BC, like over 1,000 years before Christ, right? He came up with a thing that was basically a vending machine where you put a coin or a stone, whatever they used. I don't know. I guess they had coins back then, didn't they? Probably. Yeah, in Jesus' day they had coins, right? So you put a coin in, and it does something, and it opens up a door or something like that to get your stuff. And that was like 1,000 years before Christ. Isn't that crazy? He came up with a steam engine, all right, which was, we think steam engines are fairly recent, like 1800s. Like, who's the guy that made the steam? Didn't he make a steamboat or something? There used to be a song about him. I remember learning about him when I was a kid, and I forget the name. If I had a multiple choice, I'd probably get it. I just can't remember. Not Steamboat Willie. That's Mickey Mouse. Anyway, but he did develop a lot of really interesting things that I think I saw square root. Like the square root, I think they give him credit for coming up with what a square root is. All right, so anyway, he did a lot of things. This is one of the things right here. So what in the world is a semi-perimeter? Well, the semi-perimeter is the perimeter, but what? Half of it. That's right. So let's find the semi-perimeter first. So the semi-perimeter would be, you add up all the sides. Yep, so 12 plus 12 plus 16 divided by 2. That's 24. That's 40. Divided by 2 is 20. All right, so semi-perimeter is 20. So the area is equal to, the A, B, and C just represent the three sides of the triangle, okay? So first of all, you put a 20, then you multiply it by what? 20 minus, which one do you want to pick first? Let's do the 16, all right? And then you go 20 minus 12, and then you got to do it again because you got two sides that are 12, 20 minus 12. All right? Put that all in your calculator. Bing, bang, boom. What do you get? 71.6. I didn't do that in my head. I just looked at the book, saw the answer, and that's what it is. I don't know what the units are. It's in inches. These are all in inches. So this would be inches what? Squared. Somebody in my CP class asked me as they were taking the test. They said this one problem, they said areas in inches, right? And then this other one said find the area of something else, right? Is that still, I'm sorry, inches squared, right? And they said, is that still in inches squared? I'm like, yeah, everything in area. Anytime you find area, it's always what? Inches squared. I didn't think that somebody would think that one time an area would not be squared and another time it would be squared. I don't know. Anytime you get area, it's always whatever the units are squared, okay? So you got to memorize again something. What are you memorizing for this? That formula right there. Okay. We good? All right. Let's see what else we got. So that was all the area of the triangle things. Now we are going to do a little trig. So I think we jumped to 12.6. Yeah, law sines, law cosines. So let's jump to 12.6, find a couple problems. Now, the problems I give you on the quiz, I do not draw a picture for you. But that's okay. You got numbers 4, 5, and 6, 10, 11, and 12. So let's write that down. It's section 12.6. So section 12.6. And the first problems are like 4, 5, and 6. 4, 5, and 6. I believe 4, 5, and 6, you're using the law of cosines. I think. Yes, law of cosines. And then 10, 11, and 12 law of sines. All right, so 10, 11, and 12. So this just gives you something to study. All right, you can go pick a couple of those problems, try them out, and see if you can get them right. Say that again. Is it going to be?
So on the quiz, it's going to be like this and the math.
Yeah, except the numbers could be different. But yeah, the style of problem would be the same. So let's look at 4, 5, and 6. Do you have a preference? Anybody looking at the book? Look at 4, 5, and 6. It's page 611. 5, okay. It says find angle M, or A, sorry. Find, it says the measure of, that's why I said M. Angle A, find angle A if, and here's what they tell you. They tell you that side A is 7. They tell you that side B is 12. And side C is 8. So what I would do, I would draw the triangle, wouldn't you? It doesn't have to be to scale. I don't even care, like if this is obtuse, I don't even care if you draw it as a acute triangle, okay? It's just so that we know what side's opposite what and all that kind of thing, all right? You could be able to do this without a triangle, but let's just draw a triangle. I don't know, just draw a triangle like this, like this. It doesn't matter. We could figure out if this was acute or obtuse or right, couldn't we? How do we do that? We did it not that long ago. Take the longest side. Let's just do that. Let's see what it is. You don't have to do this on the quiz, okay? This is just extra. So you could take the 12 and you square it, and then you take the 7 squared plus the 8 squared. What's 12 squared? 144. This is 49. This is 64. What's that? That's 13. That's 10 and 1. Is that right? Did I do that math right? 49, 64. So what is 144? It's greater than. So what kind of triangle is this? It's an obtuse triangle, okay? And let's just pretend that's our obtuse angle up here, okay? So if that's our obtuse angle, it's going to be opposite the longest side, which would be that one. Wouldn't you agree? Now, it really does not matter, okay? You could draw a triangle any shape at all and put these anywhere that you want, all right? So if that's my obtuse angle, that would be 12, so that would be B. So that means this would be angle B. The shortest one is 7. This looks like the shortest one, doesn't it? So that's opposite A. Of course, this would be C, and this would be 8. All right, so if you wanted to make it a little bit more to scale, right, make it look like what it's supposed to, you could do that. A equals. All right, what do we got to do? We got to find what? Angle A. So how are we going to find angle A with the law of cosines? First of all, we couldn't use a law of sines, could we? Because you need to know, well, you need to know at least one angle, right, to use the law of sines. Because if we're going to find an angle, you got to know at least one angle and 2 sides, correct? On this one, I got all 3 sides, and then I'm missing an angle. So yeah, this is good for us to use law of cosines. So what could I do here? Let's remember, these two are across from each other, right? So this is the one that's going to go out by itself. All right, so this is going to be what? 7 squared equals, and now it's pretty easy. You just take the other 2 sides, square them, right? And add them up. Minus what? What's the law of cosines? 2, and then these 2 numbers right here, the 8 and the 12, right? And then what? Cosine of the angle that's opposite the 7. What's opposite the 7? Angle A is. We don't know it, so we're going to put in A. Now, we have to get a by itself. At first, this is a little tricky, but really it's only 3 steps. 3 steps. The first step is to get rid of the 8 squared and the 12 squared. Why do I get rid of those first? Because they're being what? Being added to each other. How do I get rid of something that's being added? Subtract. All right, so let's just redo this. So I got a 7 squared on the left. What do I do with this 8 squared? I subtract the 8 squared, correct? That goes away. How do I get rid of this 12 squared? I subtract a 12 squared. That gets out of the way. Now, how do I get rid of these things? These things are all being multiplied, right? How do I get rid of something that's being multiplied? I divide. So I'm going to come over here, divide by all these. So what am I going to do? Divide by a -2. That gets rid of that. Divide by an 8. Gets rid of that. Divide by the 12. That gets rid of that. See how easy that is? What's all that equal to? The cosine of A, correct? So that was 2 steps. Subtract a couple things, divide 3 things. I'll consider that 2 steps. Now we got one more step to get angle A. How do I find angle A? Take the what? What is it? I don't take the cosine. Take the what? Inverse cosine. Thank you. Take the inverse cosine of all of this. Okay? Tell you what, I'll just save myself some writing. All right, so we just take the inverse cosine of all of this. Again, I'm going to say it again. You got to practice this, okay? You must practice putting this into a calculator, all right? It's super important. I mean, you can do all this work, get this, and if you get the wrong answer, it's going to be wrong. I'm going to mark it wrong, even if I see you showed all that work correctly. Because in math, you have to get the right answer, don't you? It's not a matter of, well, yeah, it was close, or yeah, I put it in the right formula, I just did it wrong on the calculator. I don't think it was your class. I think it was another class I said yesterday. I said, if you have an engineer that's making a bridge, right, and they do all the math right? They do all the algebra right, they put it all together, but what do? They put it in their calculator wrong, right? And they're like, okay, our bridge is supposed to have this number of whatever. I don't know how to make a bridge. I've never made one, all right? But let's say they did that, and they put the wrong thing in there, right? The wrong size, okay? It was too short, or it was too small, or it wasn't going to hold the weight of the bridge, or whatever it was. Then the bridge is going to fall down. You can't go saying, well, look, I did everything right. I did all the math right. I just messed up putting it in the calculator. You can't do that, all right? So that's the same thing here. So make sure you know how to put that in the calculator. Yeah, they had half credit, sure. There is no half credit when it comes to building bridges. It's got to be full credit or nothing, all right? So there you go. What am I doing? Number 5, is that what it is? 34.1 degrees, is that what you got? Anybody practicing? Anybody trying this right now in their seats? You should be. All right. So that should come out to it's approximately. I put equals, but you know it's approximately. It's not exactly. I'm not going to mark wrong if you put an equal sign. It's fine. Okay. Actually, on the quiz, I actually put like A equals blank. So I do put an equals here. All right, I probably should have put an approximate. I know, that's terrible of me. But you get the idea. By the way, they asked to round it to the nearest tenth, so make sure you know how to round your numbers. I don't know what the number was after this because I didn't put it in the calculator, but make sure you round to the nearest tenth. That's the first decimal place. What's that? 0.09. Okay, so that 9 did round the 0 up to a 1, so that's how we got the 1. Okay? All right. One more. By the way, I actually asked you to solve for the triangle. So that means not just find angle A. Now, that problem in the book just says find angle A. But on the quiz, I'm going to say solve the triangle. It will be. Well, it's not actually, it's 4, 5, and 6 on the homework. This is actually numbers. Oh yeah, it is. It's 4, 5, and 6 on the quiz as well. Yep. That's funny. All right, so I say solve the triangle. What does that mean? Find all the missing parts. Okay, they gave you all three sides, so what are we going to find? All three angles, okay? So we found one, 34.1, right there. So I got to find the other two. Well, one of them, I'm going to have to... you could use law of cosines again, or you're in a situation now, if you wanted to, you could use the law of sines, couldn't you? Since you know this angle now, you want to do that just to practice law of sines? All right, let's do that because we already did law of cosines. So look, I've got this angle and this. What do you want to find? B or C? It doesn't make any difference. B. All right, so let's solve for B. Well, it would be the same exact thing. Here, I'll set it up for you. I won't actually do the whole problem, but I'll set it up for you. So if you wanted to solve for B, then this is going to be what? Cosine of B, right? And then what's the side that's opposite that angle? It's 12, so it would be 12 squared, okay? So if you wanted to do it this way, that's perfectly fine, all right? What are the other ones? 8 and 7, right? So it would be 8 squared plus 7 squared minus 2 times 8 times 7, all right? And then you could do the same exact thing and solve for B. So you could do law of cosines twice there if you wanted to, all right? Or you could do the law of sines, all right? So if we did law of sines, then I know these two right here. I'm trying to find this, so I would write it like this. Sine of B over B, which is 12, equals, what are the two we know now? We know A, angle A, and side A, don't we? So I'm going to put the sine of angle A, which I already know, because I just found it earlier, over A, which is 7. Now, you getting all this? So now let's do some math. Let's get the 12 by itself. Or sorry, let's just get to 12 on the other side, not by itself, but on the other side. So we multiply both sides by 12, multiply that side by 12. And then really, what is B? It's just the inverse sine of all of this. Okay? So we're going to put that into our calculator. It's actually, putting this in your calculator is a little bit easier than putting all this stuff in your calculator. So maybe law of sines you might like better because it's a little bit easier to put into the calculator. All right, so you put all that in there and you take the inverse sine of it, and I don't know, I don't have the answer here, so because they just, on the homework problem, they just asked you to solve for angle A. They didn't ask you to solve for the whole triangle. So let's put it into the calculator. So it's 12 times, now in my calculator, I got to hit 34.1 first, then I hit sine, then I hit equals, and that's the top, and then I divide it by 7, and then the very last thing I do is take the inverse sine of it. That's on my calculator. Second function sine, 73.96, so that would be what, 74.0? Is that what you got? Anybody get 73.96 for B? What'd you get, Gabby? Okay. I might have done it wrong. So, did you get what I got? Okay. So 73.96. The 6 rounds the 9. Here, let's write this down. 73, sorry. 73.96. If I was going to round that to the first decimal place, that 6 rounds this up 1, right? So what's 1 more than 9? 10. So I got to put the 1 here and the 0 there. So what's this going to be? 74.0. All right, so if they ask for angle B, it would be 74.0 degrees. And a lot of kids say, well, why do you even need to put the 0.0? Because it's 0.0. Well, this tells me that it rounded to 0.0. It tells me that it's not 74.3. It's not 74.9, right? There's a big difference, isn't there, between 74.0 and 74.9, right? So even 0.4, right? So this tells me that it rounded to be a 0. So that's pretty important. So that's that angle right there, 74.0. Now, how do I find C? C is super easy. Once you find two of the angles, how do you find the third one? I'm not even going to do the work for that. How do you find that angle if I know these two? Yeah, you can add them, take them away from 180, or you can just say 180 minus 74 minus 34.1, all right? And whatever you get for that. I got my calculator out, might as well put it in there, right? Minus 74 minus 34.1, and that's 71.9. So that's what this angle would be. And there you go. You've solved the triangle. You found that angle, that one, and that one. Make sense? Yep. It could be 4 through 6 or 10 through 12. Okay.
Teachers and staff, last call for water aids and
What's that?
have roles in the lobby for
Oh, yeah.
10 more minutes.
Yeah, this is 4 through 6. So, like, angle A would be one problem. So that would be like number 4. Number 5 would be angle B. Everybody see this? So it's not like you got to get them all right to get just one problem right. I split them up into 3 separate problems, right? And then number 6 would be what? Angle C. Actually, I put the triangle when I give all 3 sides. That's actually number 7, 8, and 9. But it doesn't matter what numbers they are. Does that make sense? All right. So you should be good with that. So that's 4, 5, and 6, 7, 8, and 9. I do give you another triangle with 2 angles and a side. So like 10 through 12. Yep, 10 through 12, they give you 2 angles and a side. So let's do one of those. We got some time, don't we? This is 7, 8, and 9. Number 10, I'm not going to go over. Number 10 is something different. It's not math. Is what? Yeah, of course. I said the test is Monday, right? So don't worry about 10. It's not a math thing. Everybody's going to get it right. Don't worry about it. Okay? I'm positive. I'm positive. Well, why would you ask me a question about it when I say I'm positive it's going to be, everybody's going to get it right? All right, 10, 11, and 12. Which one you want to do? Anybody have a favorite? 11. Okay, so 11. So this is number 11 in the book. So it says find B, find side B. And here's what they tell you. They tell you an angle, angle A, 75 degrees. They tell you angle C is 43 degrees. And they tell you that side C is 11.
But on the quiz that's 7 through 9, right?
Yeah, it doesn't matter what numbers they are in the quiz. You just know you're going to have these, something like this, okay? Well, both of them. So you're right. I did say find B. I should have, because I was just looking at the book, right? I just forgot. You're right. This is solve the triangle. So on the quiz, you're going to have to solve for all 3, right? They give you 3 things. You're going to have to find the other 3 things. They give you 2 angles. You're going to have to find the other angle. That's super easy, right? It's finding the other 2 sides that require a little bit of work. Both of them. 4 through 6, solve the triangle. 7 through 9, solve the triangle. Okay? We straight on that? Okay. Let's draw a triangle. Let's draw a 75-degree angle. We can kind of 75. Let's click off that. There's 90. 75 would be something like that. Wouldn't you agree? And then, I don't know. It's good enough, isn't it? Again, it doesn't have to be perfect. So if we call this A, that's 75 degrees. We'll call this one C. That's 43 degrees. We can find that one easy, can't we? So what letter is that going to be? It's going to be B, right? And C, where's C? That's 11. Remember, the C, the 11 has to be across from the 43. Everybody see that? That's very important that you make sure you set it up like this. Doesn't have to look perfect, just good enough so you can see what you're missing and what you need to find. Okay? So what are we going to solve for first? What's the easiest thing to solve for? Angle B. Yeah, so how do we solve for angle B? Yeah, 180 minus 75 minus 43. And that gives you 62. So this angle up here is 62 degrees. So that was easy. So that's one of our answers. Angle B is 62 degrees. And again, how do we find it? We went 180 minus 75, oops, not equals, minus 43. Now it equals 62. All right, that was super easy. Now we got to solve for the other two. So this side I'll call B, this side I'll call little a. Everybody with me? And it doesn't say to use the law of sines or law of cosines. You use whatever you like the best, right? What are we trying to solve for? Let's solve for A. Let's do that one first. So what do you think I could use? Could I use law of cosines to solve for A? Could I? Could I use, just yes or no, could I use law of cosines? Why? You don't have B, right. In order to use law of cosines, if I was going to solve for A, I got to know the other two sides, right? So I couldn't use law of cosines. So guess what I'm going to use? Law of sines. That's it. So I'm trying to solve for A, so I'm going to put the A on the top. Remember we talked about that? It's a lot easier if you use the version of the law of sines, and whatever you're trying to solve for, that's the one I'm going to put on top. I used it earlier to find an angle. That's why I put the sine of that angle on the top before. So it's going to be A over what? The sine of 75, right? Because it's the angle opposite the side. All right. What are the two that I know? Not the 62. The C. Okay, I thought I heard somebody say 62. Yeah, the C, right here. All right. So that's C as well. So I use these two. Which one do I put on top? The 11. I got to put the 11 on top. If I put the side on top here, I got to put the side on top here, right? Over the sine of what? 43. And now you just solve for A. We made it kind of easy for ourselves because we put the A, we specifically put it on top just to make it a little easier. So all I got to do is get rid of the sine of 75. How do I get rid of the sine of 75? It's being divided, so I multiply it. And I'm just going to put it right up here. Okay? Cancels out there. And this is what you put into your calculator. All right, so let's do that. Practice it. Try it. Look, I'm doing it. You do it. All the kids are doing it. Yeah, I got 15.6. Is that what you got? Good. So A is 15.6. I don't know what the units are in. It doesn't matter. They don't give you any units. That's fine. So let's add that to our list over here, 15.6. All right, now we know that, right? 15.6. I'll tell you what, though. Remember, this is an approximation, isn't it? All right, so I would rather solve for B without using this right there. So I'm going to use law of sines again. I'll use it twice on this one. Don't you think that's the best option? Yeah. You could do law of cosines. I would not. Okay, because you would be using an approximation for it. You're still going to get an answer that's super close to what it's supposed to be. But that's what we're going to do. All right, so let's do this. We're solving for B, so you put B over the sine of 62 equals, let's go back to the C because we know both of those. So again, we'll put 11 over the sine of 43. It's almost identical to the other problem, except you're multiplying by the sine of 62 this time instead of the sine of 75. All right, and that should give you your answer. So sine of 62 times 11 divided by sine of 43. And that's 14.2. Is that what you got? Okay, good. 14.2. So that's what B is equal to. Add it to our little list, and then we're done. It's as easy as that. You good? All right. Well, we didn't have time to go over that homework. What's today? Wednesday, right? Quiz Thursday. Review on Friday. Yeah, let's just turn it in. Just turn it in. All right. So what was that? 12.5? Is that what it was? Or was it 12.5? All right. So turn in 12.5. And no homework tonight. Just study for the quiz and be ready for it.